describing a distribution in the world of statistics, if we don't mention shape, center, and spread at least 200 times between now and May, we're not doing what we're supposed to be doing, because we will say it over and over and over again. So here we go. Let's go back to the incomes of secretaries in thousands, this distribution that we had before. And we had these measures of center and those measures of spread. And notice that the mean and the median were very close to each other. This standard deviation is very comparable to that interquartile range. The measures of center don't differ much because the distribution was fairly symmetric. And these measures of spread in the overall scheme of things don't really differ too much. But what if we did this? What if we added one more salary? We added a secretary making $96,000 a year. Maybe she's working for some dude named Madoff and he's starting a new company, and ironically he's going to call it, like, I don't know, Enron or something like that. So good luck. But anyways, we got an outlier now. So we got this secretary up there that's making a whole lot more. That is an outlier. How will it affect our statistics? Well, what's going to happen is measures of center, the mean is going to go from 34.4 to 40. It's going to be affected quite a bit by adding that one large score. The median's only going to go up a little bit to 36. The mode will remain unchanged. The range is going to take a big hit. It's going way up, very much affected. The IQR, the interquartile range, is not going to change at all. Standard deviation is going to get extremely inflated, as is the variance. So we can see that the presence of one extreme score can have a drastic change on the mean and the standard deviation of the variance along with the range. How come the mean changes so much? Well, we were adding 10 scores up and dividing by 10 to get a mean of 34.4. But when we add this 96 to the mix and divide by 11 scores now, the mean is pulled way up. So the average score is increasing by over $5,000 a year. Standard deviation, same kind of thing. Remember how we take every deviation, we square it, we add them up, divide by one less than the sample size, take the radical of everything. But by adding a 56 squared, a deviation of 56 squared to all these other scores in here, and they would change a little bit compared to what the new mean is, but you get the idea. One huge deviation added yanks the standard deviation from 7 to over 19. So what we say is that the mean is not resistant to extreme scores, and just one extreme score can have a huge effect on the mean average. But we say the median is resistant, it doesn't change by much. And in fact, if you have a big data set with several, dozens or more data points, then what really happens when one extreme score is added is a lot of times the median won't change at all. It'll pretty much stay the same because it's just that score that's positioned in the middle. Standard deviation also is not resistant to extreme scores. It went from 7 to over 19. The IQR is resistant. Go ahead and add one extreme score, but we're still looking, where is that range where the middle 50% of all the scores are? That's hardly, and that's not at all affected by the extreme score. So we can see that, that this is good. The IQR is resistant. So now we need to consider the shapes of distributions. We have two of the most common symmetric distributions would be uniform, where things are evenly distributed. Think of a team all wearing the same uniform. They all look the same. So there's the same frequency. It could be discrete. There could be just a countable number of values that the variable could take on. Or it could be continuous, like speeds on a road or something like that. So whether it's discrete or continuous, as long as it's evenly distributed, we refer to that as uniform, and it is symmetric. It's symmetric about a line of axis. Bell-shaped. It can be discrete and have this bell shape to it, or it can be continuous. And the most famous of all distributions would be a normal curve, which is bell-shaped, continuous, and has certain other characteristics to it. Then we have the two most common asymmetrical, I just don't know how to spell the words, not symmetric distributions. We have skewed left and skewed right. So wherever the distribution is being pulled to, wherever it's tapering off to, that's direction where the that's the direction where the skewness is. So that's what skewed left looks like, whether it's a discrete distribution where there's only a few values that the variable can take on, or infinitely many values, a continuous distribution. So skewed left and skewed right. You can imagine now, see, skewed right, if we have extreme scores, they pull the mean average way up. One extreme score can make the standard deviation get really huge. So it's these asymmetrical distributions, these non-symmetrical distributions, that will affect the mean and the standard deviation drastically. So we're not supposed to report the mean as the center or the standard deviation as the spread when the distribution is not symmetric. So this is what we need to understand. When you describe a distribution, three ways: what's its shape, what's its center, and what is its spread. So the shape, if it's symmetric, like uniform or bell-shaped, we report the mean and the standard deviation because there's no extreme scores, there's a nice balance of scores, so we aren't going to have the mean and standard deviation yanked up unless there's an outlier present. If the distribution is not symmetric, particularly skewed left or skewed right, or again, if there's some outliers present, then we should report the median and the IQR because they are resistant to those extreme scores. So that's what you need to commit to memory, but understanding it is even better. You need to understand, why would we not report the mean and the standard deviation for a skewed distribution? It's simply because the mean and the standard deviation get affected drastically by extreme scores one way or the other. So it makes sense if you understand in addition to memorizing. Now let's see how this applies. A lot of times you're going to be asked to compare two distributions. So let's look at Class A and their test scores, and these are the four statistics that we have for those. And then we'll look at Class B and those four statistics, 2 measures of center and 2 measures of spread. Now let's go back to this guy. Hopefully we can see from this box plot that the distribution is skewed to the right. The median's over here and things really start to taper off, and then there's a couple of outliers. So we are not supposed to report the mean. Over here we should report the median for our measure of center. So when we're comparing center, we would compare 70 here to the correct center here. Now you can see it doesn't matter if we report the mean or the median, they're the same, which more often than not with symmetric distributions they're going to be identical or very close to one another. Officially, since it's symmetric, we should report the mean. Now check that out, here's the deal. If we report the mean here and correctly report the median here, then we would say on average the scores in this distribution, in this class, were lower than the average score in this class. But if some yahoo didn't know the difference between when you're supposed to report the mean or the median, they would say, hey, you know, the measure of center over here is up here at 78, and so, you know, the average score over here is only a little bit lower than the average score over here. Well, that would be incorrect. You have to report the correct center and the correct center, so the average here is a lot bigger than the average of this distribution. Then we go to the measures of spread, and again, because this is a skewed distribution, you are not to report the standard deviation, you are to report the IQR, which isn't affected drastically by those extreme scores up there. So IQR should be reported here. Whereas over here, since this is symmetric, the standard deviation should be reported. Now, if you're taking an AP exam and you were to compare these two distributions, you need to say shape, center, and spread for both of them, and then draw a conclusion between the two, or you're not going to get the full points. So over here we would say Class A is skewed right, that's the shape, with the center, which is a median of 70, and it has a spread, an IQR of 14 points on this test. Class B is symmetric with a mean, a center of 80, and a standard deviation of 12. That's its spread. Now, for the sake of comparing the two, so we can do apples to apples, when it comes to the spread, we choose to report IQR for both of these. So we'll say, you know, just so that we can kind of report two things that are measuring the same, even though standard deviation is appropriate because it's symmetric, we'll say, well, you know what, the IQR here is 20 and the IQR here is 14. So even though this looks to be not as spread out, it's actually more spread out. So the IQR here is 20. We just drew this x-axis a little bit narrower, so don't be deceived by that. So there's a little bit more spread outside of the outliers here. There's actually a little bit more spread with Class B. There's a little bit more variance in Class B. Now, when it comes to reporting the average, we should report the mean if we have it, and the median here if we have it. So we would say the average score here is 80, the average score here is 70, so this class is outperforming on average this class over here. So difference in shape, symmetric versus skewed right, difference in average, the average here is about 10 points higher than the average here, and difference in spread, even though standard deviation is appropriate, for the sake of making a comparison, we'd say this interquartile range is bigger than this interquartile range here. Describing these distributions, you get in the habit of saying that if the mean is above the median, when the mean, actually I should say, if the mean differs from the median, that's when you tend to have skewness. In fact, if we go back to this one, take a look at what happened. Remember how the median, 70, was down here, but the mean was way up here at 78. So when there's a big difference between the mean and the median, that suggests that there is skewness, and it's in the direction of where the mean is. So since the mean was bigger than the median, that suggests that the distribution is skewed right, because it's the extreme large scores that are pulling the mean average up. Now, what you tend to see if you have a symmetric distribution is that the mean and the median are either the same or they're very nearly the same. So if you're not given a picture of the data, but you're given like a computer printout of some of the statistics, the thing you look towards first is, how does the mean compare to the median? Well, this is very close. 78 and 79 are very close together, especially in relation to the lower quartile and the upper quartile. So we would say that this distribution is fairly symmetric. Now, what gets a little bit subtle is, when you go over here to this mean and this median, it's like, hey, they only differ by 2, so that's not a very big difference. But wait a minute, the difference is relative to the rest of the spread of the distribution. Over here, there's only an IQR of 5 from the lower quartile to the upper quartile. So the fact that the mean differs from the median by 2, that's 2/5 of the entire interquartile range. That's actually very significant. This distribution is actually skewed. Now in this case, since the mean is below the median, it's skewed to the left. So you want to focus on the difference between the mean and the median, see how big that difference is in comparison to the lower and the upper quartile, and if you need to, if you still don't quite see it, then it might help to draw a box plot. So what we can see over here, if we take the 5-number summary, the min and the max, and the 3 quartiles, the lower quartile, the upper quartile, and the median, if we put a box plot together from that information, we can see that this distribution is fairly symmetric. There's a little bit more spread down here on the lower end, but it's fairly symmetric. Whereas when you make a box plot of this data, there's not as much spread, but you can see the skewness to the lower scores. It's being pulled down here to the lower scores. So that is skewed left. So because it's skewed, you should not report the mean, you should report the median. And you should be reporting the interquartile range, the difference here being 5. So that takes care of that distribution. This guy is symmetric with a mean of 78 and a standard deviation of 20. That would be the appropriate thing there. Now again, if you're asked to compare these two distributions, then you need to draw a conclusion. The average over here is 79. That compares to the average over here, which is about 78. So they're pretty comparable. The spread, again, for the sake of comparison, we can go IQR versus IQR. There's much greater spread here with this data. So symmetric, skewed left, comparable averages, but more spread with this distribution over here. This distribution, we can say, whoa, look at this. Look at the difference between the mean and the median. That's a big difference. This must be a skewed distribution. But hold the phone. Upon further inspection, if you look at the difference between the lower and the upper quartile, that's roughly 400 points. So there's a 400-point gap in the IQR, the middle 50%. So for the mean to only differ from the median by 35 points, that's less than 10% of the total spread in the IQR. So there's not that much of a difference. So you could say that this is approximately symmetric, or you could say that it's slightly skewed to the left because the mean is below the median. Either answer would be appropriate as long as you can justify it. But again, the big idea, check to see whether there's a difference between the mean and the median, and then is it a very big difference relative to the IQR? In this case, not a real big difference relative to the IQR, so you'd probably go by saying that this is roughly symmetric or slightly skewed to the left. Again, either one of those two answers is correct as long as you can justify it about what we're saying there. So there it is. This is the big idea. Whenever you're asked to describe a distribution, boom, you pull out of the deep, dark resources of your brain, shape, center, and spread. We have to get in the habit of always describing those three things. If it's symmetric, mean and standard deviation, and do you remember why? Because they're okay. There's no outliers, there's no extreme scores to yank those guys up. If it's not symmetric, we can't report the mean and standard deviation because extreme scores will drastically affect those guys right there. They are not resistant to extreme scores. The median and the IQR are resistant to extreme scores. That is why those are what we use for center and spread if it's either not a symmetric distribution or if outliers are present. So there it is, shape, center, and spread, describing distributions.